Hey Pike Panthers, it's Mr. Little again, and I thought I would start by saying today we're going to learn something that you already have some familiarity with. What do these words, gravitational pull, axis, rotation, and equator, hemisphere, tilt, and revolution, a thermometer, a flashlight, and a globe all have in common? Well, if you said the answer is seasons, you are absolutely correct. So before we begin, I think it's probably in our best interest to talk about one of the fundamental forces of the universe, and that force is gravity. Gravity holds all objects in space, irregardless of their size. If they are larger, they do exert a greater amount of gravity, whereas if they're smaller, they still exert gravity, but not nearly as much. So, for instance, even I am exerting gravity upon the Earth. But because the Earth is so large in comparison to me, the Earth doesn't really feel my gravity. But we certainly feel the Earth's gravity when we try to jump up and come straight back down. So that is really important that we understand that it's the force of gravity that keeps all objects in the universe in their orbits. It's the whole reason that the Earth orbits around the sun. Even little old Pluto, which is millions of miles away from the sun, is still held in check by, you guessed it, the sun's gravity. So the question that we need to answer is, what are seasons and what are the factors that are important? There are a couple factors that are essential for determining seasons. If you've ever gone outside on a summer day, especially in Texas, you know that it's extremely hot. Winters, occasionally it gets cold. For the most part, it's fairly mild. And then, of course, spring and fall are kind of in between. But why is that? Why do we have such differences in temperature between the different types of seasons? Well, there are two factors that we're going to learn about today, and that is tilt of the Earth's axis and the Earth's revolution around the sun. First thing that we need to be able to establish is that we know the seasons in order. If you don't know the seasons in order, it's going to make it very difficult for you to understand many of the concepts. For instance, if we start with summer, we should know that fall comes after summer. We should know that after fall we have winter, and after winter we have spring. Now what's unique about our seasons is that when I pull up my globe right here, and I'm going to expand the screen so you can see me again. There we go. You can see a couple things. The globe is obviously tilted. It's not for aesthetic value. The people who make globes didn't decide one day to say, oh, you know what? How are we going to go ahead and make this globe? Well, the fact of the matter is that the Earth is tilted at 23.5 degrees on its vertical axis. And that is hugely important when we start talking about the reason for the seasons. Okay, so axis is one thing that we need to make sure we understand, is the Earth spins on an imaginary axis. As it travels through space, it's spinning around. It is in essence what gives us our day and night. So while half of the globe is bathed in light, half of the globe is in darkness, and they are experiencing day and night respectively. Now, one of the other big things that we need to talk about is the differences in hemispheres. Hemispheres might be a new term for you all. Hemispheres simply relate to the northern hemisphere, which is this area above the equator, and the southern hemisphere, which is below the equator. Now, if we look at our current season here in Texas, we're experiencing spring. Interestingly enough, if you're in the southern hemisphere, you're experiencing the complete opposite season. So if it is spring here, it is fall down here. When we are having Christmas in cold weather, Australia, which if I can get it here, there we go. Australia is experiencing Christmas in the middle of its summer. Bizarre, huh? But really, anything that is in the northern hemisphere is completely opposite of the southern hemisphere. Now, as I mentioned earlier, rotation is one of the vocabulary terms that we need to understand. And it's quite easy. Rotation tells me an object that spins on its axis. So again, if I take this globe and I spin it around, it spins on an axis, an imaginary line that runs from the North Pole to the South Pole. and it is completely responsible for giving us our 24-hour cycles, our day and night periods, if you will. It takes the Earth 24 hours to make one single rotation. Now, the next thing we need to understand is what's called revolution. And unfortunately, it has the same beginning letter as rotation, and sometimes kids find it difficult to understand or determine what's rotation and what's revolution. We'll get to that here in just a moment. Revolution is in the path an object makes through space. So if I take a look at this Earth, and I don't have the screen to go ahead and really show you, but if I extend it outwards, and I'm acting as the sun, as the Earth moves around the sun, it is experiencing a revolution. And this, along with the axis, the tilt of the axis at 23.5 degrees, is what gives us our seasons. And this is why the tilt is very, very valuable. When I take a look at my globe here, and you can see here's Texas right here, and I can see that the northern hemisphere is pointed more directly towards me if I'm acting as the sun, which means it's getting more direct energy from the sun. The southern hemisphere, on the other hand, is pointed away from the sun, so it's getting less direct energy from the sun. Now, the axis doesn't change as it goes around the sun. If I were to go ahead and look at 4 different positions of the Earth around the sun, I could say that this is summer for the northern hemisphere, which obviously means it's winter in the southern hemisphere. As I move it around, and now I'm in front of you, what comes after winter, or after summer, kids, in the northern hemisphere? Fall. And then if I move it over here, try to capture it in the video. Okay, now you can see the southern hemisphere is getting more direct energy. It's pointing more directly towards the sun versus the northern hemisphere, which is now pointed away. That means that the northern hemisphere is now getting winter, and the southern hemisphere is now getting summer. And then, of course, as I continue on, you would know what season comes after that, obviously. Okay, so we need to differentiate between rotation and revolution. I think one of the best things that I've always told kids is, when you think about rotation, think about the word itself being smaller, okay? For me anyways, it helps me to think about, okay, it's rotating, it's making small movements, rotation. And if I look at revolution, which is a larger word, it's bigger, so I try to equate that to an orbit around a central object. That's always been one of the premises that I've used with kids in the past, and it's been used fairly effectively. So the intensity of the sun, we talked about that. Believe it or not, during the summer here in Texas, and this is actually a fallacy. This is where if you were to ask your parents the same question, they might get it wrong. You might want to ask them, why is it hotter in the summer than it is in the winter? And a lot of times people are going to say, well, it's because we're closer to the sun. That is absolutely incorrect. Believe it or not, we are closer to the sun during our winter period. So during the winter, we're actually distance-wise slightly closer to the sun. But why are our temperatures so vastly different? Why is it still hotter in the summer versus the winter? Well, the fact of the matter is that during the summer, the sun is right overhead. We're getting more of the direct energy. And that's where the flashlight that I wanted to use was coming into play. If I were to take a piece of paper and shine it, and you can't really see it from your vantage point, no, that's probably not going to work very well, but if you shine it down on a piece of paper, you'll see that it basically shines on a very small area of the paper. During the winter, even though I'm closer, the light is actually spread out. I actually have now much more surface area that I'm covering, but the intensity of the light is very, very different. Finally, the last thing that we want to talk about is solstices and equinoxes. The best way for you to remember the differences is this. Think about the prefix of equa, equinox, equal. Equinox means that we have equal numbers of hours of daylight and nighttime. So during the fall and the spring, we have an even amount of daylight hours. During the summer, which is oftentimes called the summer solstice, that's when the sun is right overhead, like I said before, and it's high up in the sky, and it doesn't set for a long time. In the wintertime, it's just the opposite. It's called the winter solstice, and that is when we have the shortest amount of daylight. And a good measure of that, if you've ever been outside, maybe you've noticed that during the summer, your shadows aren't very large. That's because the sun, again, is right overhead. Whereas in the wintertime, the sun is more kind of at an angle, and now your shadow is spread out further along the pavement. So it's a valuable clue to help us understand where we're seeing the seasons and how the sun is reflective of our differences in temperatures. So I'm going to cut over to the slide or to the notes. We're going to go through it real briefly. A lot of this is going to be redundant, but I did want to make sure that we did cover it. I've got about 4 minutes left of this, and then I promise I will get you on your way. So if I can figure this out, we'll go ahead and cut over to the reason for the seasons notes. And for the most part, I am going to read it verbatim. Seasons are due to the tilt of the earth as it travels around the sun. We have spring, summer, fall, and winter. And you can see there's a great image right there that shows the earth in its different positions, if you will, in relation to seasons. Earth's revolution is the circling of the earth around the sun. It takes 365 days for the earth to revolve once around the sun. Technically, it's 365 1/4 days because every 4 years, if you know, we get a leap day. So we have to account for that, and that's why 365 days and a quarter is technically the better answer. Now, the axis of rotation, as I said before, is an imaginary line going from the North Pole to the South Pole. It's obviously not there, but the Earth does spin on this imaginary axis, and it's what gives us our day and our night. So 24 hours is how long it takes for the Earth to revolve one time around its axis. And this next part, pretty important, because without Earth's tilt, we wouldn't experience seasons. The Earth's tilt is 23.5 degrees. Imagine if the globe that we looked at earlier wasn't tilted. Let's assume that the Earth wasn't tilted. How might that impact our seasons? The Earth's tilt is vital, along with revolution or orbit, to give us the seasons that we experience throughout the year. So the orbit, like I said, is the path that a planet takes as it goes around the sun, or a moon as it takes as it goes around a planet. So our moon is revolving around the Earth is revolving or orbiting around the sun. Okay, and I mentioned earlier that the direct sunlight covers a very small surface area. The heat's very concentrated and it's warmer as a result. The sun is high in the sky, so therefore summer heat energy is very direct. Whereas with indirect sunlight, you can see now, if I pan back up here, you can see here my flashlight is right overhead and it's got a very small surface area. But if I cut down here, you can see when I angle the sunlight that I cover a larger surface area, but it's spread out when it reaches the ground. And because of that, the sun's low in the sky, the winter's heat energy is very indirect. Okay, so again, we covered the fact that we have seasons because of Earth's tilt of 23.5 degrees. Make sure you know that, kids. 23.5 degrees is pretty important. Okay, how does tilt cause seasons? Well, like I said earlier, Earth revolves around the sun. Earth tilts towards or away from the sun. Earth tilts toward the sun in the summer, and it tilts away from the sun in the winter. And I'm going to go ahead and, even though this is a bit redundant here, I do want to cut over to one other set of notes here so you can see what I'm talking about in terms of the axes. So this is just another thing that's going to be on Google Classroom. Oh, look, there's the anchor chart. It's also right behind me. Okay, so you'll have access to the anchor chart, which is everything that we've been talking about today. But if you look here, rotation, revolution, you can see that it's spinning on a central axis. It gives us our day, our night. Revolution gives us our year. It takes 365 1/4 days. But here's where I was going. If you look down at this one right here, look how the axis is tilted differently than if I were to look at this one. The axis is now tilted in the opposite direction. Be careful when you're answering questions like that. If I look here, I can see that the southern hemisphere is getting more direct energy from the sun, so therefore it's summer here and winter in the northern hemisphere. Whereas up here, now it's just the opposite. My axis in this particular graphic has flipped. The northern hemisphere is getting more of the direct energy and the southern hemisphere is getting less of the direct energy. And hopefully you enjoyed that. That concludes the Reason for the Seasons notes. Have a great day, kids. Bye-bye.